Square roots will be our first look into the irrational number system. Now, what exactly is a square root? Well, if we square a number and we take the square root of a number, they are opposite operations. So when I think of a square root, I always think what number times itself equals that number, and whatever that base number is, that is my answer for a square root. Now, we have different kinds of square roots. We have something called a perfect square. And that's when we have a whole number times a whole number. Like 25 would be a perfect square because it's 5 times 5. And we have a lot of perfect squares. So if you think 1 times 1, well, the square root of 1 is 1 times 1. The square root of 4 is 2 times 2. Notice they're all whole numbers. The square root of 9 is 3 times 3. Why do we call them perfect squares? Because they actually make squares. A 1 by 1 square, a 2 by 2 square, a 3 by 3 square. And right there we can see that relationship going back to that squaring of a number. Now, what most people don't realize is that there's two ways to get a positive whole number. So yes, I can do positive 2 times positive 2 equals 4, but what I can also do is negative 2 times negative 2. So perfect squares actually have two answers, both a positive answer and a negative answer. So when we talk about the square root of 4, our correct answer would be plus or minus, meaning positive and negative 2. So all perfect squares have that. But notice there are a lot of numbers missing here. I don't have a square root of 2, a square root of 3, a square root of 5, a square root of 7. The reason why is because remember, by definition, a square root is a number times itself. Well, to get 2, it has to be 2 times 1. That's not times itself. Now, it doesn't mean that we can't take the square root of 2, because we can. We can take the square root of any number in our number system. The difference is that my answer is not going to be a whole number. My answer is going to be a decimal. And usually we put those inside our calculators. And a lot of the reason why square roots are under the irrational number system, it's because an irrational number in decimal form never ends, never repeats. And that's frequently what a lot of our square roots do. So a lot of times if we don't have a calculator with us, we just estimate what our perfect square or what our square roots are for numbers that are not perfect squares. So say I take the square root of 5, which I did not have up here, and the only way I can make 5 is 1 times 5, so it's got to be some sort of decimal answer. Well, what I think about if I'm going to estimate it is I think, all right, what are the two perfect squares 5 is between? Well, 5 is between the perfect square of 4 and the perfect square of 9. And I know the perfect square of 4 is 2 times 2. The perfect square of 9 is 3 times 3. So my answer for 5 has to be somewhere between 2 and 3. Now, whatever number it's closer to as a perfect square, that's what I would estimate. Well, 5 is only 1 away from 4, so it's closest to 4. Therefore, I'd say that the square root of 5 is about 2. And I can do that with any of the numbers. If I take the square root of 15, well, 15 comes between 9 and 16. And so what is it closest to? Well, it's closest to the square root of 16, which is 4. So I would say that's about 4. So perfect squares always have whole numbers as answers. The other numbers that we take squares of, the square root of, they're going to be a decimal answer, but we usually just estimate. So that brings us to, can you find the square root of a negative number? Well, no. And the reason why is a square root is a number times itself. There's no negative number that I take a number times itself. Because if I take negative 16 and take the square root, the only way I can get that number is negative 4 times positive 4. Those aren't the same numbers. They're on opposite side of 0 on the number line. So there is no way that you can ever take a square root of a negative number. However, square root signs are grouping symbols. So I could have a negative on the outside because remember, by definition, negative means opposite. So if this were the case, I would find the square root of 16, which is 4, then I take the opposite. So you can have that negative outside the square root symbol, but you can't have it inside the square root symbol. So lots of kids think, okay, well then square roots are only for whole numbers. Nope, we can do fractions as square root. And the way that you're going to look at your fraction for a square root is you take the numerator by itself and the denominator by itself. So the square root of 4 is 2 times 2, which is 2. Square root of 25, which is 5 times 5, is 5. So the square root of 4/25 is 2/5. So you're just breaking it down. Think of numerator by itself, denominator by itself. And we can do that with any of them. So 4/16, the square root of 4/16 would be 2/4. But if it's in fraction, remember we have to reduce to lowest terms. So all those rules of fractions remain. So then it takes us, well, we can have square roots with equations, and we solve them just like we do any other equation. So if I had 5y squared equals 110, my first job is I have to get y squared by itself, and we know that we use inverse operations for that. So I'm going to divide both sides by 5 because we have to keep it balanced, and I get y squared equals 22. Now remember, I don't want to know what y squared is, I want to know what y is. And because square roots and squaring of numbers are opposite operations, in order to get rid of that square, all I do is take the square root, and it literally cancels each other out. So the square root of y squared is y. Square root of 22, this would be one that we would put in the calculator because it's not a perfect square, plus or minus, because positive or negative, 4 16/900. So a lot of times for square roots we do have to use our calculators for that, but everything that we've learned about solving equations remains the same. So then that takes us to expressions, and remember I said square roots are a grouping symbol, so that means we have to solve our order of operations within the symbol before we come outside the symbol. So if I have this expression, the square root of b squared minus the quantity a plus 15, okay, I see an exponent, I see subtraction, and I see addition, and I see parentheses. Clearly that's order of operations. And I know that a is 48 and b is 12, so my first job is I just have to substitute the values in. So I replace b squared with 12 squared, I replace a with 48. Now I have to start with parentheses first, so I'm going to do my 48 minus 15, 48 plus 15, which is 63. Then I have to do my exponent second, so I do 12 squared is 144. Then I solve within the symbol, so I do 144 minus 63 is 81, and we're lucky here because 81 is a perfect square, so I take the square root of 81, and it's plus or minus 9. So everything that you've learned up to this point, we keep applying. Don't let these radical signs, which is what a square root is called, it's called a radical, don't let those scare you. You still do exactly what you've learned to do up to this point. We're just applying it into the irrational number system. You're going to have fun with these. I love square roots. Good luck.